All right, geometry, hopefully this is helpful. Couple clarifying comments. I'm going to focus on factoring here, okay? And I'm going to try to hone in on one particular method. There's different ways to do different problems, and I want to focus in, well, I'm going to focus in on two a little bit, and try to help you guys understand how to do these, okay? I'm not really focusing on FOIL, distributive property. I think that's pretty straightforward. If you have questions, I'm not trying to make you feel bad about that. Like, come talk to me. Okay, there are some subtleties where you could get stuck on that. But I just want to give you a big picture of what factoring is as we're seeing it come up a little bit more and knowing you're going to see it in Algebra 2. So as we're talking about factoring, one of the things I want to talk about first is making sure that you understand there's different ways to factor, right? So the different ways there are would be as follows. Let me just pull this up a little bit for you. Okay, when we're factoring, we're really dealing with quadratics, okay? And so we're trying to think through these methods. Just as an aside, factoring is really asking, if I asked you what the factors of 8 are, it's asking what two numbers multiply to 8. So something like 4 or 2 or 8 and 1. But what we're dealing with are more complicated ones, like if I have something like this. You know, what two numbers multiply to this, okay? We'll talk more about this exact example later, but the idea is we're thinking through what numbers would multiply to this. And there's really these kind of 5 ways to do that. Okay, we're going to focus on, you can see here, we're going to focus on this first way, right? Some equations will not be factorable this way, but for the most part, and we're going to focus on this last way. But ultimately, because these are graphs, these are all parabolas, and we're finding where the graph crosses the x-axis, you can solve using a graph. You can use square roots. Sometimes that's pretty straightforward depending on the problem. Right? You could complete the square. So these are kind of 3 other ways. We're going to focus on way number 1 and way number 5 here to solve these. All right. And again, most of my time through this video is going over this first way. Again, when this equations can be factored, that's the question, can they? So we'll walk through that and we'll run into some problems. Hey, what if we're doing one and also we realize it can't? Maybe we need to shift gears a little bit. But as we're thinking about this, all right, what we want to do is recognize some of the really common factors that'll come up. So again, I just want to make sure we're thinking about this. What we're going to focus on is 2 things. Number 1, what do we do if you have this? Okay, what do we do for most cases when a equals 1? We'll take a look at that. What if a is 1? So that's our standard one that basically you'll see most often in algebra problems, basic algebra problems. You focus in on this. And then what if a equals 1? We'll take a look at some. What if a does not equal 1? What do we do in those cases? Right? This is more along the lines of maybe you would do quadratic formula. You don't have to all the time. We'll talk about that. All right. And then some of the things that'll come up. So I want to give you the most basic one. We're going to talk about this situation for a minute. If we're looking at this, if a is equal to 1, so I'm actually even going to erase it. If I'm looking at this problem, there's actually only 4 situations you're going to run into. Okay. And this is not including some shortcuts. So we'll talk about some shortcuts in a minute. All right. You can have these 2, and you can have these 2. All right. And what I said in class, what we talked about is when you're factoring this, you're really coming up with 2 binomials that multiply. Okay, and so what you're doing is, you know, since this is x squared, you're going to have 2 x's here. So this is the same on every one of these problems, which is really nice as I start to solve these. Okay. Now, before you get really excited and you're like, oh, that's not too bad. Again, this is making an assumption that the x value, the a value in front of the x squared is 1, right? It would look like this, all right? So we got all of these. Now, what I would try to tell you and encourage you is there's different ways to do this. Okay, different people do this. And I always thought this was helpful for me. I always start by looking at the second sign. And the second sign is going to tell you what the symbols are here. So you look at the second sign, And it tells you if it's a plus sign, then your symbols, and by your symbols I mean the pluses and minuses down here, will be the same. And all you have to do then is check the first sign, and that tells you what they're going to be. Here they're going to be plus, plus. Here they're going to be minus, minus. Okay? If that second sign is a negative, the symbols will be different. Meaning you're going to always have one plus and one minus. So one plus, one minus, one plus, one minus. What's nice is if you check the first sign, okay, on both of these guys, the bigger number. Actually, let me do this in yellow so we're clear. All right, the bigger number, we'll look at some examples, goes with the sign. Okay, and by the sign I mean this guy right here or this guy right here. Right? So what I want to do is take a look, again, in this situation, let's take a look at an example. That would be like this. Okay? All right, so I know right away I'm going to do something that looks like this. I have an R here, I have an R here. And the first thing I'm going to do is I'm going to look at this sign, which is a minus, which I told you is a plus and a minus. And then I'm going to check this guy right here. And I know that the bigger number, we'll explain that more in a second, the bigger number is going to go here. Okay? So to proceed and figure out the numbers, really what we're asking is, what are the factors of 30? What two numbers multiply to 30? And I'm going to list them all out. I know you guys don't need this, but I think it's helpful. Just want to be consistent the way I'm writing those. All right, notice those are all of my factors. I know that it's all of them because the next one would be 5 times 6. Notice I'm kind of decreasing here, increasing here. Once you get a repeating number, you know that. So I do that, and I look at these and I say, hey, out of these numbers, if I add them together or subtract them, which one would give me this other number, this number that's right here? Okay, so I kind of come up with the factors of 30. These are all the factors of 30. Which one of them is, let me simplify this a little bit, there's a 1 in front of there. Which one of them is 1 apart or add or subtract 1? Notice if I did 6 minus 5, I would get 1. Okay, and so I know my two numbers are 6 and 5. Okay, we're always saying this, and I want to be clear. You ask yourselves, what multiplies to this? What adds or subtracts to this? What multiplies to this one adds or subtracts to this one? And I said, again, the bigger number goes with the sign. So since this is a negative sign, the bigger number gets that, the smaller number goes here. These are my factors. If I took these two, okay, joy of joys, I could do the distributive property here and check my answer. If I did the distributive property, okay, again, maybe you learned it as FOIL, I should get back to this original answer. Okay, so this is kind of the big picture of these, okay, these general ideas. Again, there's some shortcuts in there, but this is the general idea. And you'll see this throughout your worksheet. I started at number 11 because that was the first factoring one. I could look at this one, and it's very similar, right? So I would look at this one, and I would start with this. I'd put a K here and a K here. Since this is a minus, I'm going to put a plus and a minus. Since this is a negative, the bigger number is going to go here. I think through all of my factors of 28. Okay, so 28 is 1 times 28, 2 times 14, 4 times 7, all right, and I think 7 times 4 would be the next one. So those are my factors. There's not a ton that time. And I notice that if I add these, I would get 29, 16, 11. If I subtract them, if I added them this way, if I subtract them this way, I would get 27, all right, 12, and 3. This is the one I want, okay? You don't need to do this every time. I just think it's helpful to see there's lots of combinations, okay? Some of you would sit there and do some guess and checking. This is where you could run into some trouble, okay? Which one of those, again, adds or subtracts the 3? So I got that number there. And so now I plug in my two numbers. The negative should be the bigger of these two numbers, which is the 7. My 4 goes over here. Those are my two answers, okay? Then we get to like problems like the next one, number 13. And all of a sudden, this one looks a little different, okay? And so when we look at something like this, you can still factor the same way, okay? There's one little trick you have to think through, right? It's a little bit longer of a process. I actually really like it. It's going to come in handy, so I'm going to talk about it. But before I do that, I'm going to do the quadratic formula. All right, the quadratic formula. Okay, so this is the formula, and when you're looking at these problems, it's really nice. This is, as we said before, this is A, this is B, this is C. Really nice. All I'm doing is plugging in. Negative 11 plus or minus the square root of 11 squared minus 4 times 5 times 6 all over 2 times 5. One of the things I would want to be really careful about, sorry I erased that, is the A, B, and C include the sign. So all of these are positive, but if this was a negative, then you'd have a negative in here somewhere, okay? So you have, the rest of the time, you can be really careful and punch this all into your calculator. If I'm doing this one at a time here, you should get 120 there. Divided by 10. And so I have negative 11 plus or minus the square root of 1 over 10, which equals negative 11 plus or minus 1 over 10. And I'm going to get two answers. You have negative 11 plus 1, which is negative 10 over 10, which equals 1, negative 1. Or I have negative 1. Or I could do the same thing, negative 11 minus 1 over 10, which equals negative 12 over 10, which equals negative 6/5. Notice this one. I got this ugly answer. That scares me a little bit for factoring. But it is factorable. We could do this. So I just want to show you the factoring way. So quadratic formula. Notice a little bit of work here. Again, I could go back to here and type this pretty much all in on a calculator. You'd have to do one for the plus, so make it a plus sign, type it in, go back, make it a negative sign, plug it in. There are some practical complications if you don't know how to use a calculator that will come up. Okay? Let's say I was factoring this. Okay, not doing what I'm doing. In order to factor this, what you have to do first, multiply A and C. In this case, I'm going to multiply 5 and 6. 5 times 6 equals 30. You have to come up with the factors of 30 first. Unlike the last one where we came up with the factors of 28, now we're going to come up with the factors of 30. In fact, let me do this in pink. 5 times 6 equals 30. We're going to come up with factors of that. So if I'm thinking about these, again, you would have 1 times 30, and 2 times 15. We already did these. 3 times 10, 5 times 6. And I actually want the ones that add or subtract to 11. So I'm still looking at the same process. I just had to do this one step first. This is going to give me 11 if I add those. Okay? This is the weirdish part. I'm going to rewrite this in same equation, okay? 5n squared. Watch what I'm going to do. Okay? I rewrote 11n as this. Okay, and the reason I did that is so I could do this thing called grouping. Number 2. So in step number 2, I'll write it this way. Second, split. So split your b sub x or bx, right? Like we did here, we had 5x right? 5x plus 6x. This could get a little tricky. Sometimes it's a little harder. And step number 3, third, we're going to group. And by grouping, you're just grouping the things that look similar to each other. So you've got one group here, right? And you've got one group here. And you're asking yourself, what do these have in common? What do they both have? They both have a 5, and they both have an n. And you're left with, if I divide this by 5n, you're left with n, and you're left with 1. What do both of these have in common? Okay, you're left with, you factor out a 6, a positive 6, so you're left with an n plus 1. And what you're looking for is what we found on this step, that this guy here and this guy here are the same. What that does for me is this. I have n plus 1 times 5n plus 6 plus 6. Okay. If you distribute this, you're going to get something that looks like this. If you distribute that, you're going to get something that looks like this or this. Okay. Now, I don't know if you see our answers. We got 1, negative 1, and 6 over 5. Negative 6 over 5. If I take each one of these and set them equal to 0, n plus 1 equal to 0, you're going to get n equals negative 1. And if I got this guy, 5n plus 6 equals 0, and you solve this, you end up with n equals negative 6 over 5. Okay? I know this might seem complicated. It doesn't have to be, and there's some nice problems where this is actually a really nice method to do it. So if it's helpful to watch this part again, I would do it. Otherwise, you could do the quadratic formula, okay? Similar here, I would look at this and maybe I'm just going to show you the quadratic formula here. Really quick, I'll write it over. So negative 13 plus or minus the square root of 13 squared minus 4 times 2 times negative 7 all over 2 times 2. Punch it in on your calculator, you're going to get an answer. Okay? If I'm grouping 2 times 7 equals, 2 times negative 7 is negative 14. Factors of 14 are 1 and 14. Okay? 1 plus 14, notice, is going to be 13. So I'm going to factor this. 2x plus 1, sorry, 2x squared plus 1x minus 4, sorry, I said that wrong, minus 1x plus 14 minus 7. Okay, again, it looks a little weird. Notice the middle terms here. Or rewrite that. Okay, I'm not going to change it, but I just want us to see 2x in black squared minus 1x plus 14x minus 7. These two add up to this guy. Okay, and then I could group these guys together and these guys together. You have x in both of these, left with 2x minus 1. You have a 7 in both of these, so you're left with 2x minus 1. Again, these are the same, so you have 2x minus 1 and x plus 7. Here's your x, here's your 7. And set each of these equal to 0. So x is going to equal 1/2 for this guy, and x is going to equal negative 7 for this guy. Plug this in. Lots of math happens on your calculator, or really carefully by hand. You should get the same answers. Okay? So either one of those options is there for you. Okay? 18 is a little different. I wanted to show you something like this because notice this one, there isn't any C value. It's just A and B. So on these, you're really asking, can I factor anything out first? What do these both have? They both have an M. And I'm left with 3M plus 8. These are my two factors. Like there's not really, my factors are, again, technically we're setting these equal to 0 when we factor. So n could equal 0 if I let this guy equal 0, or if I set this equal to 0, 3m plus 8 equals 0. Subtract 8, subtract 8. 3m equals negative 8, divide by 3, divide by 3. However you'd like to write it, you can write, there's a negative, sorry, negative 2.66666, repeating, lots of different options. Okay? All right, and then there is this one, and this is the other thing I wanted to talk about a little bit. There are some problems, some really nice ones that if you catch are really helpful. I'm thinking of 3 in particular. Oh, sorry. Summarized by this kind of formula. 2ab plus b squared. Another one, a squared minus 2ab plus b squared, and then another one, a squared minus b squared. All of these are perfect squares, okay? Well, not this last one. It's just a nice shortcut that has to do with perfect squares. What I mean, maybe to say this differently, the first number and the last number are perfect squares. First number, last number, first number, last number. When you see perfect squares like this, 9 is a perfect squared, and x squared is a perfect squared, 16 is a perfect squared. So when you see these, there's some nice little shortcuts. This thing always, all the time, is a plus b squared. This one all the time is a minus b squared. And this guy, a little different, a plus b times a minus b. Okay, and what I'm going to say is, I'll put some examples up in a second, but if you want more on this, I'm happy to kind of walk you through more. I can give you some other examples to walk you through. But basically, if I saw an example like this, x squared, I think I've written this one before, plus 6x plus 9, you've got a perfect square and a perfect square. And so what I end up with is x plus 3 squared. Okay. What is the square root of x? Squared. Sorry, what is the square root of x squared? Is x. What's the square root of 9? 3. And what is 2? Sorry, 2 times a, 2 times x times b, which is 3. 2 times x times 3 is 6x. Okay. Very similarly, let's say I gave you a different one. It said x squared minus 12x plus 36. X minus 6. 6 squared, 36. Again, even negative 6 squared is positive 36. X squared is x squared. And negative 6 times x is 6, negative 6x times 2. Again, negative 2ab. Negative 2 times x times 6. Okay? And then this last one is actually this case that we're looking at. Okay? To make this look a little bit more like this, you actually have 16 minus 9x squared. I'm going to write it a little differently, just so it looks more like this. But notice, perfect square. So what's the square root? Basically, just so we're clear on it, this is going to be my a, and this is going to be my b. Right? They're squared. And so I'm looking at that through that mindset. So what I would do is simply ask, what is the square root of 16? We get 4. What is the square root of 9x squared? Square root of 9 is 3. Square root of x squared is x. And so you do a plus version of this and a minus version of this. And that's your answer. Okay? Technically, your answer is x equals negative 4/3 and 4/3. Because you have to set each one equal to 0 and solve. Okay? But I want to make sure that we see this. If I took not my answer, my final answer, which is what this is, it's my final answer. If I took these and I actually did FOIL, I want you guys to see how this one works out. I would have 16 minus 12x plus 12x, and you can see right here, these guys are going to cancel out, and then minus 9x squared. Okay, so you end up with the original term. Okay, so hopefully that's helpful. Again, I didn't go over every problem, but hopefully enough that you're getting the idea of what you're supposed to do and how to get these answers for your final answer. If you're stopping short here, notice when they ask you to factor, you really do have this. If they ask you for x, you're going to go a step further. So these are the factored answers. I just like to connect it to this idea because they go hand in hand as you look at all of them. What is the value for m that makes it work when it equals 0 is normally the flow of thought in a lot of the questions that you're going to be asked, especially in Algebra 2.